So welcome back, students. So this particular lecture we will be discussing about hot working and cold working of metals. So from the plastic deformation theory, what we can summarize is that ductile materials have better load-bearing properties compared to brittle material. So from the previous lecture, we can see that any material which is manufactured using casting process tend to be brittle in nature. So if you have to use those parts which are manufactured using casting in load bearing applications, then you have to change the properties of those materials. So that can be done with the help of metal forming process. So what we do in metal forming process is that we can improve the material properties by heating the metal to a recrystallization temperature. That is one way. Another way is applying mechanical load on the material. When you apply load on the material, it tends to deform. So that deformation causes the enhancement in the properties of the material. These are the two major ways we can increase or enhance the property of materials. So based on the application of heat, that is, if you are heating the material, whether you are heating the material to recrystallization temperature or not, based on that process, we can classify the metal forming process into hot working and cold working process. So this figure will clearly give you an idea of the metal working process, particularly the hot working process. So as I said, hot working is done at a temperature above the recrystallization temperature. 1 minute. So this will be your material before deformation, before subjecting to deformation. As you can see, these things are the grains, and these are also grains. So these are larger when compared to these grains. So this will be your cast part, initially part which is made using casting. So when it is heated, what happens is that the grains will get deformed. Before that, these two rollers are applying load on the material. So when load is applied, as you can see, when load is applied, the grain starts to stretch. So when you apply load, what happens is that the grain starts to stretch. These round globules become stretched like this. After that, when heat is applied, as I said, when you heat it to recrystallization temperature, new grains are formed. As you see here, the grains, these stretched grains get dissolved and new smaller grains are formed. So this process enhances the properties of material. What properties are enhanced, we can see. Porosity of the material is largely eliminated. These larger grains tend to leave the material porous. But when you apply heat, what happens? New grains are formed and porosity is reduced. Grain structure of metal is refined. From larger grains, smaller grains are formed. And mechanical properties such as ductility and toughness are improved. And also deformation of metal is easy because when you heat the metal, it tends to get softer. So softer metal is easy to deform. So that's the reason we are going for hot working process. So the point to remember here is during the hot working process, the grains, larger grains are deformed or dissolved into smaller grains. There may be some disadvantage to this hot working process also. So as you can see, it requires very expensive tool. The reason being, you are subjecting the material to higher temperature, heating it to a recrystallization temperature around 700, 800 degrees Celsius. So tool which is used to apply load should be able to withstand that recrystallization temperature. For example, if you are using a steel die in a hot working process of manufacturing steel, what happens? The die also tend to become softer at the recrystallization temperature. So that is very, very disadvantageous. So what you have to do, you have to use a material which has higher recrystallization temperature or higher working temperature than steel. So that tends to increase the cost of the tool. That's one thing. Poor surface finish. So when you heat the metal, what happens is that surface becomes rough because carbon tends to deposit on the surface. Whenever heat is applied, the carbon from the inner surface will move to the upper surface. And also carbon from the surrounding atmosphere may be trapped there. So when carbon is trapped, it becomes hard. Hard material always have rougher surface compared to softer material. That's the second disadvantage. And then another thing is close tolerance cannot be maintained. Tolerance, we have discussed, it is the acceptable range. Acceptable range cannot be small for hard working process, because once you heat the metal, it becomes soft. So once it is softer, we cannot control the dimension of the material. So that's a reason, some disadvantage of this hard working process. So if you do not need these disadvantages, then you can move on to another process which is called as a cold working process. So cold working process, what happens there? It is done below the recrystallization temperature. So how cold working is done, we'll see in the next lecture video. Thank you, students.